Well, hello there, statisticians. This is your professor here, and I am checking in, made this video here to help reorient you to the use of SPSS for doing your analyses. I'm going to focus on just the single sample t-test, but what I address is going to apply to pretty much all of the analyses we do for the semester. So a couple of reminders. I'm here on the home page of our Canvas class, and if I scroll down, I want to remind you that there is a tutorials page, and if I click on tutorials, you see several links for dealing with SPSS. This last one here is important if it's been a while since you forgot how to access and import data files into SPSS from the textbook website. The data files, for example, for the single sample t-test need to be accessed and downloaded and then imported into SPSS to use them. And you'll be doing that, again, data files for most of the class. So give that a look to refresh your memory on how to do that. But let me just, as a real quick reminder, the textbook resources page, there will be a link to it on pretty much any of the chapter pages from here on out. So if I were to go to chapter 5, single sample T, and scroll down, there we go. You see the textbook, chapter 5, textbook resources. When I click on that link, I'm taken to a window, and this is the statistics website for our textbook. And when I click on chapter 5, there's several resources here that are helpful. Under the lecture videos, these are some videos that your textbook authors put together on the various concepts discussed in this chapter. And so if you were struggling with some of them, that the textbook or my lectures still left you a little bit confused, give those a watch. There's the spreadsheet calculator to find the p-values and the tail and body values for z and t scores. And next we have information specific to each of the activities. And notice the very first link under activity 5.1 is data for activity 5.1. And then there's data for activity 5.2 and data for activity 5.3. So you'll need those three separate data files to do your analyses. And below each of the data files are some videos that giving you instructions for how to do the analyses that you're asked to do in the activity. And so you see, for example, there's one for SPSS where the textbook author, Jennifer Winquist, shows you how to do the analyses for that activity. So give that a watch. If you're at all confused, and I'm sure you will be, with how to do the analyses in SPSS. All right, the instructions are right there. And by the way, your textbook, that video, your textbook author makes the comment that SPSS does not calculate effect sizes. And that was true back in the version of SPSS that she was using when she made the video, which was version 25, I think. But we're using version 29 here at Palomar, and 29 does provide effect sizes and confidence intervals. So really, you don't have to do any calculations at all for chapter 5 and pretty much from here on out. So there is the chapter resources. By the way, as long as I'm here, we are on this chapter resources tab. If you look in the upper right corner, right next to that where it says software, if I click on that tab, it will take me to some links for the various software options. If you are having troubles using the VMware to access SPSS, Jamovi and JASP are two free open source software applications that are fairly small and can be installed on both Mac and Windows-based machines. So it might be a little bit more convenient if you wanted to use one of those. So here's the link, and then there's manuals and stuff if you really wanted to dig deep. But you can install those and use those for your activities as well. And if you remember, looking back, going to chapter 5, for example, there are, in fact, videos for using Jamovi and JASP for each of those activities. So Those are options available to you. If you don't want to use SPSS, perfectly fine. Jamovi and JASP, I've used them both. I've used Jamovi a bit more. Super easy and fast, and you don't have to do the whole VMware login thing. Okay, but instead I am going to assume that you have watched that video, downloaded and imported your SPSS data file into SPSS or Jamovi or JASP, and have done the analyses. And now my main purpose for this video is to show you around the output, so you understand how to read the output. So I am going to open up an output file that I have here. And this is actually from chapter 5. You can see I labeled it activity 5.1. This is not SPSS that I'm in. I took the activity file and I exported it as a PDF. And so this is me opening that PDF file. You'll notice a lot of these tables that look like this here where it says notes. That's basically just a little bit of a log file for everything that you did for that session. So we can just scroll back by that and ignore it. Same thing with the case processing summary. You can skip that. Then if you follow the instructions given in that video, you'll see a list of descriptive statistics like the means and the confidence intervals and the medians and the minimums and maximums. You all know what descriptive statistics are, so that'll be listed in a table. Now, I did the graphs first because if you remember, Fred's first rule of data analysis is always visualize your data. So that video instruction sheet, she did the graphs after she ran the analyses. Excuse me a minute. There. I just like to do them first. So there, for example, is a histogram in SPSS. You can see the descriptive statistics in the upper right. Pay attention to the scores on the x-axis. Notice that 0 for this particular activity is here, and the table is shifted a little bit to the left. So think about what scores in the negative direction might mean, and that's kind of where the trend is in these data. And then further down, there is the box and whisker plot that shows the median and the upper and lower quartiles and so on. All right, another analysis. So we get another log file because instead of doing graphs this time, I was doing the actual analyses. So when you do a one sample or a single sample t-test in SPSS, you're going to be presented with, I think, 3 tables. Yeah, 3 tables. The first one, where it says one sample statistics, these are the descriptive statistics. Notice here's the variable that we used. The n was 103. Let me use my, there. The n was 103. The mean was negative 4.06 with a standard deviation of 12.5 and the standard error of 1.241. So you should all know what those statistics are. We learned about those earlier in the semester. The next table is the result of the one sample t-test. And notice right here at the top, it says test value equals 0. As you'll see in the instructions, you enter the test value, and that is basically mu for the one sample t-test formula. It's the score that you're comparing your sample mean to. And in activity 4.1, they were comparing the estimates of time it would take to complete a task to 0, meaning 0 difference between what they estimated and what they actually spent on the task. So that's what we're comparing it to see if their estimates differed from the actual time. Then we have the actual t-test results, and you'll see the very first column is t. That is the value of the t statistic, negative 3.271. Degrees of freedom, if you remember, degrees of freedom is typically n minus 1. There were 103 people in the data set, so we have 102 degrees of freedom. And to get a t-value that large with 102 degrees of freedom, the probability of that is 0.001. SPSS is now printing both one-tailed and two-tailed p-values. And if you remember from my lecture, I want you to default to a two-tailed p-value unless the problem specifically says, hey, this is a one-tailed test. All right, we're going to follow the textbook, even though I think you should always do a two-tailed test pretty much no matter what. But in this case, a two-tailed test is appropriate, and a p-value of 0.001, which means there's a very low likelihood of a difference this large happening just because of sampling error. It's probably a real world effect. And then the mean difference column is just the difference between the sample mean, which was 4.06, way up here, and the test value, which was 0. Well, negative 4.06 minus 0 is negative 0.04, well, negative 4.058, which rounds to 4.6. So that's just the difference. That's the numerator of the t statistic. Now, because I copied and pasted the output file into a document it was exported into a document, the table on SPSS normally continued on, but it had to wrap down because of the margins. So the 95% confidence interval portion of that table normally would have been connected and just gone straight across, but it wrapped around on mine. So you'll probably see it in one line when you do the analyses. At any rate, here are the lower boundaries and the upper boundaries for the 95% confidence interval that we learned about in Chapter 4 and discussed more in Chapter 5 of our text on how to interpret those, right? We look at how far apart they are, that is how much spread there is, and then also if the implications or our interpretation changes at either extreme. So there are the results of the t-test and the confidence interval, pillars 1 and pillars 3 that we've discussed. And then here's what is new is SPSS now provides the effect sizes and the confidence intervals around the effect size. We learned how to do Cohen's d. And so in this top row, here's Cohen's d. You can skip the standardizer because the standardizer is just the denominator of the formula. It's basically the standard deviation of the sample mean. The point estimate, this value right here, is the actual value of Cohen's d. If you took the mean difference and divided by that standardizer, you get negative 0.322, which means that if we could or not even if we could, that the sample mean differed from that test statistic by about a third, 0.322 standard deviations. And then next to that is the confidence interval around the point estimate. So if we could test the entire population, the population means would likely differ by somewhere between negative 0.52, there's the lower bound, and then this table once again wraps around because it's printed in a document, to an upper boundary of negative 0.12. So the interpretation is the same. We look at the spread of them, and if things change at the extremes, the point estimate we interpret on a 0.2, 0.5, 0.8 small, medium, or large scale. And that's everything. That is an entire one sample t-test for these particular activities and where to find the information that you need to answer the questions in the activity. I happen to do all of the analyses, so if I keep scrolling down here, you see activity 5.2. And it's the same thing. We see, there we go, there's the histogram and the box and whisker plot. And then we have the statistics and the one sample t-test, etc. An important note, for each of these new t-tests, you're going to have to update the test value with the proper comparison, the proper mean, the proper mu that you're comparing your sample mean to. So remember to change that when you do the analyses. But otherwise, the commands are the same for each of the activities. And that is about all that I have to show you. I hope this was helpful. Let me know if you have any questions at all on how to read an SPSS output for your activities.